I guess it's probably then from my hometown to work. I guess since from my hometown it's something like 600.
So 600 is the point.
It depends what you compare.
Also about 40 clients. It's changing. This is sometimes quickly. Some startups arriving and it doesn't matter.
You can have one client. That would be more than 50 clients.
Yeah, sometimes
For example, in our business, we have maybe 3 clients who are critical. All others are how to say that data generators and that's it. We don't very much so if we understand all the rest of well, this must be
sometimes one is so upset if you doesn't have one in your mind. In your mind basis. Client is when you have that.
All right. Oh wow, that was fun. Maybe I don't need this at all. I'm just going to do this. So welcome, and I hope you all had a very good lunch. The final speaker of the day actually don't need an introduction, but I'm going to give him one anyway. It's our own Devrim Gundes, who is running all the packages you run on your servers. So he's the provider of all these. And he will talk about scaling your Postgres database. But before we start with the actual talk, we have a housekeeping question. This talk will be live streamed on YouTube in 360 degrees. Is anyone not okay with that? Then we will turn it off. So if anyone has objections to this, and I'm deadly serious, we will turn it off. Unless, we will keep it going. So, is anyone objecting to being live streamed on YouTube?
Any objections about the live stream? Again, it's 360. So you can see yourself tomorrow. Or right now if you want. Hey!
Hey. All right. Then we'll actually just go on with the topic. So, without further ado,
thank you. Thank you. Like spend all the conference in here as a host, room host. Like it's a bit different to be a speaker. So, welcome. Thank you, Daniel. I'm Devrim Gundes, but I am the PostgreSQL guy with the tattoo. I have some fakes over there, Okay, but that's me anyway. So, seriously speaking, I'm working at Enterprise DB as a principal assistant engineer. This is my Twitter handle. I mostly tweet about Postgres and Linux and Red Hat now. In general, anyway. So I started using Postgres in 1998, so I'm quite newish as compared to some other people. I'm responsible for the Yum repo, and starting yesterday, we also announced the SUSE repo. So if you're a SUSE user, you can also download the RPM. So I spend lots of time with this. I also contribute to Fedora and CentOS as well, the upstream projects, like maintain about these pages or so. I'm a dad. I'm soon to be another dad, like in 6 weeks time. Thank you. So working in Enterprise, I live in London. And if you are from London, or if you're around London, actually we started organizing regular meetups. The first one was last month. The other one will be next month on November 16th, and third will be December 14th. So if you're around London, please come and visit us. If you wanted to be a speaker, you're welcome. And I know, because I was a room host, I told you, and I know that many people either are dealing with the laptops or their cell phones. I'm sure you were busy tweeting about the Postgres conference, right? No? WhatsApp? Facebook? Okay. So, may I ask you, please, just use your phones right now. Please, it's not mandatory, but I'm going to give you 1 minute. Say something about the Postgres conference, please. And please use this hashtag and mention these guys, so that their phones will start buzzing in a minute. Please write something, please. I mean, if you are using a laptop or a cell phone, please use your Twitter account. Tweet about something about the Postgres conference, preferably something good. But it's up to you. So, how many people are there here in this room? A Postgres user. I mean, they're actually using Postgres on production. How many people? Wow, great. So, and I'm sure you have big data. Come on, everyone has big data, right? If you don't have big data, then you have big data, I'm sure. So, everyone loves scaling, right? We have to scale. Like, I've been talking to lots of customers, like they say, we have a large database. Okay, tell me, 10 gigabytes, wow! We want to scale, wow, how many servers? 4! Come on. So, anyway, this talk is going to be about real scaling. And I want to thank first Bruce Mumchen and my colleagues at Enterprise DB for the scalability slides, and Tom Brown, which I'm going to show you later on, for the tests and numbers. So, what's scalability? So basically it's about to handle more load or more data. Okay? So there is something in Wikipedia. So the system is considered scalable. It is capable of increasing its total output under an increased load when you add some kind of hardware. Okay? So some kind of hardware is something that we are going to talk right now. I mean, vertical or horizontal. By the way, if you have any questions, please raise your hands. Keep Daniel busy. Okay. Off now. You don't have to wait until the end of the talk. So, what is scalability again? I'm talking about the database scaling. So, it's the ability to increase the database throughput by utilizing additional resources, but I/O, memory, CPU. So this is the way that we can scale our databases or additional computers. Okay. So vertical or horizontal. Again, it's like big data, right? We need to scale out your database because we are big company, right? We have to do everything in 10 machines on the cloud. Machines? Anyway, 10 instances on the cloud, right? And then we have the cloud anyway. So in order to start talking about scaling first, let's get some data. Like, I mean, we are engineers. pretend to be engineers. Anyway, so we have to get some data first. as other people mentioned in their talks earlier, you can use PGMeasure or your monitoring software like PAM, POA, etc., and or use PGSet statements. So get some data first. Then you are going to see whether you actually need the scaling or not. So, first, vertical scaling. Vertical scaling is actually scaling up or down. So it doesn't have to be in a positive way. You can scale down, right? It's not right and left, okay? It's up and down. So it means increasing or decreasing. Because, you know, we have some managers out there out there who believe that they can do more with the smaller hardware, right? And it's all of like the DBA's work to deal with those loads. No. So either you can have more or less memory or CPU, or faster drives. As you can see, I didn't talk about slower drives. Don't do this. Okay? So it's good for virtualization, but the problem is we have the single point of failure, right? If you want to add more hardware, it means you are going to start within the same hardware. Okay. And of course, then the hardware costs are going to increase because we are going to use a single machine, larger machine, which should handle more CPUs. Okay. So which you cannot buy from your favorite market, okay? So you have to buy real hardware to scale better. So let's talk about a bit more about vertical scaling in Postgres, which is you can add more system resources and you can add more I/O. Like you can use table spaces. How many people are coming from Oracle work? How many people attended yesterday's talk about the Oracle and Post, which was an awesome talk, to be honest. So, I mean, you know, we have our table space concept is a bit different than Oracle. A bit different. So, we treat them as a directory, which I'm fine with this anyway. So, another thing, you should use separate drives for WAL. This is the Postgres Performance 101 course. Please always use separate drives for WAL because you are going to have much more I/O normally, usually, for your database. So now we scale it better. Or you use connection pooling. Okay. So let's talk about what's available within the core Postgres core database and the core Postgres. First of all, upgrade. I think last week I saw this quote from Tom Lane. Someone asked about upgrading from 9.4 and 9.2 to 9.6. And the question was whether I can, what kind of hardware will I need? So his answer was clear. You are going to need less. Because it's going to be absorbing the several years of performance improvements in Postgres. Every major release, we try to add more and more from the performance point of view to Postgres, which I'm going to mention later on. So make sure that you are using the latest version, okay, latest major version. But just be careful. 10 was released just a few weeks ago, on October 5th, I think. And so don't use it immediately in your production. I use it anyway, but see what I mean? See the latest available at 9.6 something. Make sure you're up to date. That's critical. And in 9.6, we had some great improvements. I'm going to show the numbers about scalability. Parallel sequential scans, joins, and aggregates means now Postgres can benefit from your machine, the hardware, in a better way, can utilize. Or now maybe it's time to increase the hardware. Because Postgres now is able to use more CPUs, faster CPUs, both, right? So if you want to upgrade, you may also want to consider upgrading your data, the hardware as well, not just database. So in 9.6, 6, we increase the performance with multiple servers. It's about the logging, by the way. We utilize the machines and more CPU and better parallelism. Okay? In Postgres 10, the improvement in parallelism is much better. Now we have parallel B3 scans, just B3 for now. Okay, so if you are using the other indexes, they are not scanned in parallel for now. With the heap scans, merge joins. Okay, so then now Postgres can scale my laptop. The great workstation. Okay, so. However, please do not assume that upgrading your instance to 9.6 or whatever is going to boost up everything. No. Because one of the things that I have seen on the field is, let's say you have a query, large query, like data warehouse query, say, starts with insert and a huge select statement. Okay? When you run the select statement in parallel, it runs great, like in a few milliseconds. But when there's an insert, it doesn't run in parallel. It means that overall, the whole query will not run in parallel. So there are some limitations which still exist. And we are working on this. I mean, not me, but people are working on this. So consider, I mean, it means to increase, the vertical has some limitations, okay? So, what about horizontal scaling? This is a slide that I got from Bruce Momchan's talk. So we have the master node, and then the regular streaming application. So the full copy of the data exists on every node, and then there is a PG pool instance, and the loads are distributed into multiple nodes. So if you add more machines, like more commodity machines, like cheaper machines, maybe, right? I mean, it doesn't have to be the highest level something. Then you can increase your the amount of data that you can get from your instances in a given time. Okay. So the question might be, which I don't have the numbers before you ask. Let's say if you add 4 nodes, are you going to have a performance improvement by 4? I don't think so. Because there are still lots of overheads, like PG pool or some other things. But of course it will increase performance. Okay? Any questions so far? So, what about PostgreSQL? So, it's not essentially a horizontal scaling. Let's better start with horizontal scaling. So, PostgreSQL is used to create foreign tables. Which actually resides on another Postgres instance. I mean, instance, not maybe I wouldn't say database, but let's say instance. Okay, instance on another machine. So, let me try to explain what can be done in here. So you can move a few of your tables to another instance. I'm talking about actually moving your data. Let's say if you have T1, T2, like T1, 2, 3, and 4 tables, 2 tables in one server, 2 tables in another server. Then you can create foreign tables on the master node, and then it means you don't have to change anything on the application side. The servers are going to connect, the applications are going to connect to the same node, the master node, but data is going to reside on the other server. Until 9.6, this was just, we didn't have enough performance until 9.6. I'm going to show you a few numbers from my colleague Tom Brown. So this is what happens if you are not using 9.6. Okay? So every query. So let's say you want to query a data which lives in a foreign table, foreign table anyway. First, the data is queried from the database, from that instance, moved over the network. I'm talking about all of the data. Moved over the network to the master instance. Postgres is going to do some like joins and etc. and serve the data. So it might be a bit worse as compared to the as compared to keeping everything all together. So this is what we had in the previous version. So see, the same query in this example takes 13.5 seconds. Right, 13.5 seconds. Okay, let's scroll. The same query. Now it has changed because starting 9.6, we have the option to push the joins to the remote machine. It means Postgres, the remote Postgres is going to get the relevant data, only just data that you want from that machine, give it to the master node, and it will be given to you. See, the same query, just by upgrading, now takes 4 seconds. So, when we move our data from one node, some of the data, not everything, from one node to the other, and by using PostgreSQL, you can benefit from those features. And good thing, I may be wrong. Okay, so I may be wrong, but either 9.6 or 10, maybe someone can correct me. We have parallelism as well on the remote side as well. It's 9.6 or 10. Okay, so we have parallelism on the remote side as well, which makes things easier. Okay, so this is how the query plan changes. See, the remote SQL is executed, SQL executed on the remote machine, which is going to save the CPU cycles on our side. Okay. Any questions? So, I'm sure you already know about logic verification because there was a great talk in the last sessions, I think, by a guy who actually wrote the code. Logic verification version 10 accepts write from replicated tables, but this is not multi-master, and there's no conflict resolution, limitations exist, etc. Okay, but in the future releases, if we can keep on developing the feature, we can benefit from logic verification from the scaling point of view as well. So you can spread writes. Okay, but we are going to talk about spreading writes in the later slides. This is not the end. Okay, so what about sharding? Sharding is one of my most favorite features from the application point of view, and also now in the database point of view as well. Years ago, actually, that was one of the things why EDB hired me. I was working on sharding the database with Red Hat Cluster Suite, right? So put some of your data from, there are two types of sharding, right? If you shard through the application, then you can put some of your data into your server 1, the rest in server 2, server 3, server 4. You can scale as much as you want because all the control is, all the logic is in the application. Just perfect. Then you can use the cluster suite, just fail over, switch over in between. Okay. But then you have to find the shard key and where the magic happens. Okay. So the data is split across multiple tables, databases, or instances. This is another good way of sharding. So this is the basic diagram of sharding from the application side, application-based sharding. So we have data nodes. It depends on you. It depends how you want to like spread the data in multiple clusters. Okay. So let's say people whose name starts with from A to K in the first machine, L to P in the second one, R to the Z in the third one. As long as you have the logic in the application, you can even spread the first one into 2 or second one into 3 as much as you want. So applications send queries based on the sharding layout. In this case, there is no Postgres magic. Right? I mean, this is pure application magic. Of course, you can add some replicas in here, as we discussed earlier, and use some ggpool magic if you want to do some more reads and writes. I'm sorry, not write reads from here. So, then we have some external solutions as well, okay, which helps you to scale your database. The first one is, total random order. I'm not going to say first. One of them is Citus. And in the last 2 years, I think, they started distributing the Citus database as an extension. It used to be a Postgres fork, but now you can just install the package, or compile the code, and just create the extension. And then you can start running Citus. So it supports, it supports 10, not just 9.6, 10, 5, 9.6 and 10, and at the same time. It's stable, it has write and read scalability. It actually gives you more than this. So this is a quick diagram of how Citus works. Okay? So it's a simplified version. So there is a coordinator node, which handles the table metadata. You have data nodes, goes up to whatever. Then on each node, we have Citus installed. As you can see, data node 1, data node 2, and data 3. And then we have the shards over there. So you can distribute the load onto multiple machines easily with Citus. Okay? So, of course, Citus has some limitations, but it's promising again. Anyone Citus from here? No. Okay. So, Greenplum. Greenplum is one of our old friends. Greenplum is world's first open source MPP database. It's a Postgres fork. Unlike Citus, when you want to install Citus, you can use your Postgres advanced server whatever database and just add the extension. Okay. But this is a Postgres fork. So it delivers high analytical query performance on large data volumes. And it does everything in an automatic way in a shared nothing architecture. So data lives on separate places. The data load is quite high, and actually the numbers here, each additional node to greater than 10 terabytes per hour. Which is awesome. If you're handling with large database, not the 10 gigabyte data, okay? So this gives you lots of things. It also has the read and write scalability. Any questions about Greenplum? Because we have a Greenplum developer in here. You can bug him if you want. Great. So next one, Postgres extra large. Extra large. Extra large, like this, extra large. So it's a Postgres fork with MPP capabilities. Again, it's open source. 9.6 stable. It's my bad. 9.6 stable. 10 entered alpha recently. And it also has some capabilities as well. Then we have XDB. XDB is an EDB product which does a lot of things. You can use XDB to replicate your database. Okay, I mean, that's one of the things. Or migrate your database from, say, Oracle to Postgres. Or SQL Server, like the one-time migration toolkit. But it allows writes to each node if you use XCB in multi-master mode. So actually we have multi-master replication with XCB in Postgres. Okay? Both Postgres and PostgreSQL and Postgres plus Advanced Server. It also lets you to specify the config resolution options, and it supports from 9.2 to 10. And starting 9.4, you can also benefit from the board application as well. So I'm talking about a real use case where one of your like say offices is in London, and the other one is in Brazil. You can create a copy of your database in each country or city, anyway. Then you can write into both. Then the data will be merged using the config resolution options. Now we are talking about scaling. This is the extreme case, right? It doesn't have to be London and Brazil, so it can be like Warsaw in the same data center, right? Then you can increase the scalability. And then there's BDR, which is a second quadrant product. Again, it's also closed source nowadays, and it supports from 9.4 and above. It accepts writes to all nodes with config resolution options. I think it sounds familiar with logical replication, right? Because stuff is there. So BDR features will be incorporated into Postgres 11 and 12. This is what second quadrant plans, at least. This is what I can say. And another thing, BDR 3 is going to be announced soon with some advanced features. So this is the last slide, because I'm going to leave you a bit early, I'm sorry, which you'll probably like before we need the, because we probably want to socialize with the people first before leaving here. So any questions? I want to remind you two things first. The first one is slides are going, all the slides, not just this one, is going to be available in the conference website or wiki.postgresql.org. So just visit the website soon. When each speaker uploads their slides, you can download it from there. I think it's going to be on wiki. Eventually
On the slides. On the schedule.
On the schedule. Also, thank you. So on the schedule page. So you can find the slides over there. And please don't forget to give feedback. It's 2017.pgconf.eu/f, which is easier than shortcut URL for feedback. It's going to throw you to the actual URL. So please give feedback to the conference and for the speakers as well. And thank you.